This is the video that is in conjunction with homework 1-4. It's titled Division with Remainders and Synthetic Division. We're going to talk about synthetic division in this video. So we're going to skip ahead to the second page to where it says Edpuzzle video. Here we go. A polynomial is in standard form. We mentioned this already this year. If the terms have exponents that are in descending order, meaning from highest to lowest. When terms, exponents are written in descending order, from highest to lowest to constant, essentially no exponent. So here's an example. Write this one in standard form. So we want to look for the highest exponent first, which is 2x cubed. And we're going to rewrite this as 2x cubed first. And then second's going to be x squared. And then next is going to be negative 4x, which is to the first power. And then the last term is going to be the plus 4, which is the constant. Okay, so it goes 3, 2, 1, 0. Now, we need to know that because when we do synthetic division, which we're about to do, we're going to need to have our dividend, which is what we're dividing into, in standard form. Otherwise, it's not going to work. Synthetic division is a shortcut to tabular division. It's a shortcut to dividing, but the only time it works is when the divisor, which is what you're dividing by, is a linear. So it's not going to work if it's not a linear. If we were dividing by a quadratic or something of a higher power, it won't work. So what is a linear again? A linear means that the highest exponent is 1. And a linear, if you remember from geometry, is in the form y equals mx plus b, where the x is to the first power. Okay, so if we're dividing by a linear divisor, then we can do synthetic division. Otherwise, we can't. So let's look at an example now. So here we have a dividend of 2x squared minus 3x minus 5. Dividend. And then we have a divisor, which is what we're dividing by. That is a linear. The divisor is x plus 1. Okay, so notice that is x to the first, so it will work out. So yes, we can do tabular division, but we can also do synthetic. So what are we going to do? What are the steps going to be? So if you look down below, it says steps. Step 1, set the divisor equal to 0 and solve for the root or the 0. Put this number on the shelf. So the first thing you need to know is we're going to create what we call a little box, which we call a shelf. And we are going to take our divisor, which is x plus 1, we're going to bring it over here, and we're going to set it equal to 0, and we're going to solve for x. All right? So when we solve for x, the value we get is going to be the opposite sign of what was in the factor. So if the factor says x plus 1, the root or the 0, I call it a 0, is going to be the opposite sign, which is negative 1. So we're going to put it on the shelf. Now we're going to make a big rectangle, almost like an L box. So after we put our divisor, our number on the shelf, now what we're going to do, step 2, polynomials must be in standard form. So we see our dividend is in standard form from highest to lowest. We are going to, step 3, be sure to use a 0 placeholder if there are any missing terms. So keep in mind if we had any missing terms, we would want to put that one in. We don't in this case. So now what we're going to do is we're going to write down all of the coefficients, which are the numbers in front of the x's of the dividend with their signs, including all 0 spaceholders in the box. So what do I mean by that? So go back up top. You see the coefficients are the numbers in front, including the constant. We have a 2. That goes here. We have negative 3, so include the sign. And we have a negative 5. Those are going to go on the top here in this little L that I created. Now, the next thing that we're going to do is we're going to bring down the leading coefficient, which is that highest exponent coefficient. It's a 2. And we're going to bring it down like this. Okay, remember we used to bring things down when we did long division back in the day? All right, so if you look down at step 4, it says bring down the leading, sorry guys, I got stuck. Sorry. Bring down the leading coefficient, which is the first coefficient, down to the bottom row, which put the arrow if you like. And then what we're going to do is we are going to multiply. So we're going to multiply this term by this term. Okay, multiply the number by the number that's on the shelf. So what is 2 times -1? It's -2. And then what are we going to do down the column? We're going to add these numbers up. So what's -3 plus -2? It's -5. And then we're going to multiply again. -1 times -5. What's -1 times -5? It's +10. And then what are we going to do? We're going to add. Something went wrong here. What went wrong? -1 times -5. Duh. -1 times -5 is +5. There we go. Sorry, everyone. It happens. And then we're going to add down the column. So we're going to add -5 plus +5. What are we going to get? We're going to get 0. Nice. So this 0, that last number, is going to be the remainder, which means that there's no remainder, which means that x plus 1 went in nicely into 2x squared minus 3x minus 5, which means that it is a factor. So first thing I want to do is sum up the steps that I did. The first thing I did was bring down the 2, and then I multiplied, and I put it here, and then I added down the column, and then I multiplied, and then I added down the column, and then I was done. So down below for step 5, it says we got to put multiply in here. Multiply by the number that's on the shelf. I'm going to put the number on the shelf in here. And then add down the column. And then your quotient should be 1 degree less than the dividend. So in the case of our question, we had a dividend of 2x squared. The degree was 2 because the highest exponent was a 2. So when we solve and we divide, our answer, 2x squared divided by x, should give me 2x to the 1, which is a linear answer. So the final answer is actually going to be, I'm going to throw the x back in, it's going to be 2x to the 1 minus 5. And this is the answer, the quotient. It's a linear quotient, 2x minus 5. That's it, we're done. So it's actually a lot shorter than tabular. So now I'm going to show you one more example here, and then you're going to try one. Okay, so let's look at the next one. It says example 3. I think this should be called example 2, but it's fine, whatever. So here we go. First thing, take your your divisor, and you set it equal to 0 and solve. So add 1, and you're going to get the opposite sign of what's in the factor. So if the factor is p minus 1, then the 0 or the root is going to be p plus 1. That's going to go on the shelf. So let's make a little L, make a little shelf, and we're going to put +1 on the shelf. The opposite sign of this sign here, basically, essentially, okay? Now we're going to look at our dividend, and notice we have a missing term. So let's rewrite this with a 0. 8p cubed plus 2p squared plus 0p minus 10. And we're going to put it in the box. So we're going to put 8, 2, 0, and -10. 8, 2, 0, -10. Notice I'm not taking the p's, I'm just taking the numbers in front. So now I'm going to bring down the 8. Now I'm going to multiply. So remember, we multiply by this number 1. So do 8 times 1. You're going to get 8. And now you're going to add down the column. 8 plus 2 is 10. Now you're going to multiply again. 1 times 10. 1 times 10 is 1 is 10. Just kidding. Well, it's been a long day. And then add, and you get 10. And then multiply. 10 times 1 is 10. Then add. So you're going to get 0, and we're done. So the answer is 1 degree less than the dividend. So notice in the original problem, the degree was a 3, which is called a cubic. So when I divide 8p cubed by p to the 1, my answer is going to be 8p squared, which is called a quadratic, degree 2. So we're going to put in p squared plus 10p to the 1 plus 10. So this is going to be your squared term, your first term, and this is called your constant. Notice the last box is a 0, and that means the remainder is 0. No remainder. So my final answer, which is called my quotient, is a quadratic quotient, which is 8p squared plus 10p plus 10. All right, now we're done. The last thing I want to mention before you try one, in example 4, it says, recall from question number 1 from page 1 of our homework today. If you look back at that one, we already got the answer. It says, could this have been done with synthetic division? Why or why not? Do you see that when we're dividing on this one? You have 2x minus 1. You could have done this one, but when you solve it, you're going to get 1/2. So keep in mind then you would have had to put 1/2 on the shelf. So this could have been done. Yes, it's linear divisor. It's a linear divisor. So it could have been done, but the number on the shelf would be a 1/2. Okay? So now you're going to try the next one. Notice the next one is called example 5. Give it a try. The first thing you want to note is there are no missing terms, so give it a go.